Noam Chomsky is a dominant intellectual figure in our world. He's also a professor of linguistics, a field about which few people know very much. Today we'll try to rectify that imbalance a little bit. Professor Chomsky, can you describe in a few words what modern linguistics is?
Well, it's very diverse, has many different aspects, but the parts that I've personally been involved with for the last half century or so study language as part of the biological equipment of a person, so some component of mostly the brain, which is specialized for particular tasks, including computational tasks and tasks of action that seem to distinguish us rather radically from other species, and apparently are a pretty recent evolutionary innovation. And the attempt is to find out, first of all, what a particular instantiation of this capacity is. So say the one that you and I more or less share, not exactly, but closely. Find out what are the rules and principles and so on that allow us to do what we're doing now. And more generally, to find out what is the range of possible diversity of such instantiations, possible languages, something that's determined by our genetic endowment and allows a limited variety of systems, each of which is extremely rich in expressive power. And then there are further questions like asking how, what happened in the history of these systems, how do they change from one to another, how do people use them to talk about the world or make plans and so on, how does it connect to an articulatory and perceptual apparatus, what's going on in the brain while all this is happening, someday, how did the system evolve? Hard question. This whole range of topics falls within what's sometimes called biolinguistics, the study of language as a biological capacity. And most other aspects of the study of language, language in societies, linguistic change, and so on, basically presuppose similar assumptions, more or less, sometimes explicitly, sometimes tacitly.
Your most famous sentence is, "Colorless green ideas sleep furiously." Can you tell us a bit about the significance of that sentence?
Well, actually, it had almost no significance, so I don't know why it's so famous. It was just picked as one of, if you look at, it's actually in a textbook. It was a book called Syntactic Structures, which actually was course notes. It wasn't written for publication. It was course notes for an undergraduate MIT course back in the mid-1950s, which some publisher picked up and stuck in a couple of footnotes and published. But the point of the example was just to illustrate a few elementary points, which were inconsistent with common assumptions. The question is, what makes a sentence an intelligible grammatical English sentence or any other language? One assumption was, well, it has to be meaningful in some independent sense. Well, that one isn't meaningful. Another was it has to have the proper formal elements like ly, ly, less, and so on, have to give a frame, and then you just put words in it. Okay, well, this has the same form as completely crazy sentences. I gave another example, so that can't be it. Another was that its statistical properties are close to those of English texts. So if you look at the probability of every pair of words in it, that'll be like the probability of those words in English texts. Okay, it doesn't have that property. And in fact, of the familiar proposals about the nature of English sentences, this was a short example that happened to be inconsistent with all of them. So it was one of a series of such cases, and for some reason that one became famous. I don't know why.
To me, at least, it's also always demonstrated something more positive about language. In other words, it didn't simply disprove other people's ideas, but to me, I think it's also an example of a particular computational property of language?
Well, it raises the question. I mean, I don't think it really answers anything, but it raises the question: what's going on that makes that sentence so different from, say, the same sentence backwards, or other sentences that look as if they're the same form but are perfectly fine, like, you know, revolutionary new ideas appear infrequently, say, it's more or less the same form. Why is that one perfectly normal and this one somehow a little odd? So it doesn't really answer questions. It poses the question: how are we able to understand these things? In fact, the other sentences in the list, which are, this is an introductory lecture, and there's a series of examples there. The other ones raise much harder questions. The questions about where WH phrases, you know, question words come from and how they fit and what we know about them and so on. Those are hard questions. Still lively questions, in fact.
It's often said that you revolutionized not only linguistics, but also how we study humans in general. What do you feel is the most important aspect of that revolution?
Well, this is in the 1950s, and there was a shift in perspective that was taking place from many points of view at about that time. At that time, the study of humans, psychology, was called behavioral science, and it was a study of behavior. Here's what people do, and we got to somehow figure out a way to more or less mimic what they do. You know, have a predictive apparatus that'll say, here's what they do. In linguistics, was similar. There's structuralist tendencies which were dominant, sought to identify some pretty superficial structural properties that you could find in language, and that that maybe you could find some generalizations across languages. But it was all very phenomenon-oriented. And the shift that was going on was a gradual shift, led to what's now cognitive science, was to search to really a different question. Not what are the phenomena and how do we sort of mimic them, but what are the inner mechanisms that are determining the phenomena. So the behavior, instead of being the topic of investigation, is just data. And it's useful data if it helps you understand something about the inner mechanisms. If it doesn't help you, it's not. And other data would be fine too, and so on. It actually, I think, should be looked at as a shift of the study of psychology from a descriptive, taxonomic investigation to it's something in principle part of the sciences. Maybe it'll become part of the sciences as the results become deep enough. I mean, the sciences, if you study physics, for example, you're not interested in describing the phenomena outside the window. What you study is the data by now, after centuries, comes from carefully controlled, designed experiments intended to illuminate what you take to be underlying principles of nature, which may tell you something about what's going on outside the window, but that's not the topic of investigation. The topic is the principles of nature that determine what's happening. And any phenomena are useful for this if they contribute to it, otherwise they're uninteresting. But the phenomena themselves are not the topic of study. So a physicist or a chemist or a biologist do not take videotapes of what's happening and say, okay, I'll try to find statistical patterns in this or something of that sort. That shift led to, some people call it the cognitive revolution. I don't like the phrase myself particularly, but the shift in the study of language was part of that, and also in many ways an impetus to it. Many other things modeled themselves on it, although other things were happening in the same kind of intellectual milieu, many of them going on in the same place, Cambridge, Massachusetts, in fact.
You're describing an intellectual shift, and to those of us who didn't experience that, it often seems peculiar that people, in a sense, refuse to think about the mechanism. It almost seems to have been a religious belief on the part of the earlier practitioners.
It's still true. I mean, if you counted noses of people who investigate the field, it remains very substantially a descriptive taxonomic field. That's often even a theoretical drive. I mean, you can read technical professional articles now that say all this search for inner mechanisms is pointless. What we ought to be doing is modeling the actual phenomena. So our goal is to try to develop some quasi-predictive apparatus which will yield something approximating the actual data of sentence production, which would be as if a physicist were to say, well, my goal is to model a videotape of what's happening outside the window. It's an attitude which is quite divorced from that of the modern scientific revolution, but it's very prevalent in fields that have to do with human capacity and behavior. Actually, people who study insects don't do that. If somebody's interested in insect navigation, they don't take they're trying to compile videotapes of ants running around the ground. They're trying to figure out what it is about an ant that enables it to do some rather phenomenal things, which you and I can't do. Like you and I can't carry out what's called dead reckoning. You have to do it with instruments if you're a sailor or something. But this means sort of traveling around on some random path, and when you get where you want to, let's say a piece of food, heading straight back to the nest in a straight line. You and I can't do that, but a desert ant can. And an insect scientist will, as I say, not be taking videotapes of ants, but trying to figure out what are the computational mechanisms in an ant or a bee or something that enable it to carry out extremely complex navigational tasks. Well, that's science. Taxonomy or description would be trying to model phenomena.
So when you talk about biolinguistics, what you're saying then is that we need to approach language in the way that scientists approach insects
yeah.
or any other form of animal behavior.
Or anything, whatever you happen to be studying, chemical compounds. I mean, the thrust of modern science for centuries has been to try to discover the principles, inner mechanisms, and so on, that interact in some fashion to yield some part of the phenomena that we observe. And the more advanced the science, the less they are interested in the phenomena that you find all over the place. So for really advanced science, the striking phenomena are those that are often created in the laboratory in order to test theoretical assumptions that aren't settled yet. And it's the same with linguistics. I mean, why do people study things like, parasitic gaps, which you almost never hear in speech and are pretty hard for people to understand? Well, the point is precisely because they are exotic, meaning nobody's had any experience with them, but people do have sharp and consistent judgments about them. And they answer hard questions about internal mechanisms that you would never even know exist if you just looked at the phenomena around you.
Maybe we can switch to talking about languages rather than language. Languages are disappearing at a rapid pace due largely to globalization and economic factors. A century ago, we had about 5,000 languages, give or take. And some predict that a century from now, we'll have only 1/10 of that number. How should linguists respond to those developments?
Well, first of all, I think we ought to add a corrective, which professional linguists know but isn't in the common discussion. I mean, the languages are disappearing just as fast in places like Europe. I mean, Europe had a huge variety of languages a century or a couple of centuries ago. In fact, even in our lifetimes. And they're disappearing very fast. So one of the main, as you know, one of the main linguistic projects in the world is the European Union project on what they call dialects, but they're really languages, like Italian dialects or German dialects, which are just disappearing. I mean, people can't talk to their grandmothers, because they talk different languages. And that happened through, not so much through globalization as just through imposition of national states and national cultures. So, you go back a generation or two, and Italian was a second language for almost everybody in Italy. German was a second language. You studied it in school. You spoke whatever language it was, and they were often mutually unintelligible and quite different. And they've been leveled. There's been a kind of a leveling through state formation, television, common educational systems, and so on. So in Europe alone, there's rapid disappearance of language, and the kind that we're concerned with, that you bring up, and is of great concern, is that it's happening all over the world. What linguists, of course, this is losing cultural wealth and cultural variety and the richness of human creativity and contributions at a very rapid rate. It's kind of like destroying, the museum, the library in Alexandria or something, or what just happened in Iraq, destroying the record of civilization. And a lot of this happens to be non-writing civilization, so there's no written record left. And the linguists are, of course, trying to capture as much of it as they can and try to revivify it, try to revitalize the languages. So Ken Hale, our former colleague who died recently, a large part of his life's work was trying to invigorate communities to revive and study and teach and spread their own language. And he brought people to MIT to get graduate degrees in linguistics, people who often had not much formal education, and ended up being very good professional linguists, went back to their own communities, started educational programs, took part in not only maintaining the language, but expanding, reviving knowledge of it, and trying to make it a living language again. That's happened in some places. It's failed in other places. Europe as well. So, say in Wales, without any national effort, the language kind of revived. You hear kids in the streets of Cardiff talking Welsh. In Ireland, where there was a national effort, it's apparently mostly failed. When these things work and when they don't work is hard to say, but reviving the communities, the cultures, the languages, and where that's not possible, at least salvaging the record of them, is a very significant task.
Would it be harder to do linguistics with fewer languages?
Sure. Just losing evidence all the time. I mean, if we had only, English, let's say, we wouldn't have a clue about the principles of English, because you learn about them when you study other languages. I mean, when, say, Jim Huang did the first serious modern studies of Chinese, that immediately led to discoveries about English. That it's not, you didn't learn new phenomena of English, but you suddenly realize that these are strange phenomena and they have to be explained. And that led on to other things. And the same is true of any range of languages you look at. I mean, just as if you didn't have a lot of chemical elements, you might be highly misled about the nature of elements.
Really a reverse question here. A century ago, there was great interest in universal languages like Esperanto. In fact, many of the founding members of the Linguistic Society of America were interested in questions of universal language. And some of the earliest support, financial support for linguistics came from people and organizations that were interested in universal languages. And in part, or a large impetus for that, was the feeling that people had difficulty understanding one another across cultures. there's much less interest in international languages today, in part because people say that English is now the universal language. Is that a good development, this ascendance of English?
Well, there are separate issues here. I mean, the interest of linguists, as linguists in universal languages, was based on an illusion which linguists had but no longer have. That was the illusion that Esperanto is a language, and it isn't. Esperanto is a couple of hints that people who know language can use based on their own linguistic knowledge to make a language out of it. But nobody can tell you what the rules of Esperanto are. If they could tell you that, they could tell you what the rules of Spanish are. And that turns out to be an extremely hard problem, a hard problem of the sciences, to find out what's really in the head of a Spanish speaker that enables them to speak and understand and think the way they do. That's a problem at the edge of science. I mean, the Spanish speaker knows it intuitively, but that doesn't help. I mean, a desert ant knows how to navigate, but that doesn't help the insect scientist. You got to figure out what the ant's doing. And it's now understood that that's an extremely hard problem. You go back a generation or two, it was considered a trivial problem because of lack of understanding of the nature of language. I mean, to take a kind of an analog, if you go back to pre-Galilean times, there was no problem about if I let this go, it's going to fall to the ground. It's going to its natural place. What else is there to say? Well, it turned out there was a lot to say. To be puzzled by simple questions is a very hard step, and it's the first step in science, really. And the same is true about the nature of Esperanto or Spanish, or on which it's largely based, and so on. We don't know the answers to the questions of what the rules and the principles of Esperanto do, because if we did, we'd know the answer to how language works. And that's much harder than knowing how a desert ant navigates, which is hard enough. So now it's understood that Esperanto isn't a language. It's just parasitic on other languages. Then comes a question which is not a linguistic question, but a question of practical utility. I mean, is it more efficient to teach people a system which is parasitic on actual languages and somewhat simplified, so it doesn't have some of the details of actual historical languages? Or is it more efficient to just have them know a lot of languages? And I think it's now pretty widely accepted that the latter is better, and not hard. I mean, it's a little misleading in the United States. The United States is unusually monolingual as compared with, say, Europe a generation or two ago. And the reason is not linguistic. It's that the people who conquered the United States essentially exterminated everybody. If you exterminate the native population, then ends up monolingual. But Southern California alone probably had hundreds, thousands of languages, and they're all gone, or mostly gone. So in the United States, people tend to know one. Well, actually, the languages that are spoken in the United States, which we call English, are sometimes mutually incomprehensible. I mean, I remember giving talks in eastern Kentucky where I could understand the students in the colleges because they were taught standard English as a second language, like students in Italy were taught Italian as a second language. But when I walked through the streets, I could barely understand what people were saying. Or where I happened to grow up in Philadelphia, which is urban Philadelphia. I mean, I would sometimes take the trolley car somewhere, and there'd be a kid sitting behind me in the next row, and I couldn't understand the word they were saying. I mean, they were talking what's now called, Black English, which is just another language similar to my English, but not the same. So there is a variety of languages in the United States, but much less than in areas of comparable scope, largely because of the nature of the conquest of the continent. But in many parts of the world, it's completely normal for a child to grow up speaking a number of languages. I mean, West Africa, say, maybe the mother speaks one language and the father speaks a different language, and your aunt speaks another language, and the kid just grows up knowing all of them. So it is perfectly possible for children to grow up without effort, knowing plenty of languages, and even not living in that cultural milieu. It can be done. And the question is whether that's a more efficient mode of organizing the world than teaching an extra language which is modeled on the existing ones, but somewhat leveled so that it becomes easier for, say, Romance speakers.
Linguists talk about language as consisting of a grammar and a lexicon of the words of the language. And I think one of the themes of today's discussion has been the extent to which people ask questions that they hadn't thought about before. And non-linguists, when they look at language, the questions that they ask tend to be questions about words and not about the grammar or the structure of the language. The grammar, for them, is not even worth discussing.
Because it's so natural. I mean, you just do it. Like if ants could talk, they would think there's no problem at all in doing dead reckoning. We do it all the time. What's the big problem? And we speak all the time and understand what we hear and produce novel utterances. And if linguists decide to use us as subjects, they'll give us sentences sometimes which we know are gibberish or make no sense or just don't conform to the language, and others which we have to think about and try to figure out what they mean. But we do it it feels instinctive, so what could be the problem? But that's like things falling to their natural place. There's a huge problem. Or the ant navigating. How is it done? And in fact, the same kinds of questions arise about words. As soon as you start thinking about the meaning of a word, it becomes incredibly intricate. Actually, this goes back as far as Aristotle. Aristotle raised the question, what's the meaning of the word house? Actually, he didn't put it that way. He said, what's the nature of a house? The way we would say it is, what's the meaning of the word house? And he pointed out it can't be just a collection of bricks and wood. It also must be something that has a specific design and function. So a particular arrangement of pieces of wooden bricks could be a house, or it could be a garage, or it could be, we can go out and play with it, could be a paperweight for a giant, or it could be all kinds of things. What it is depends on the design in the mind of the creator, the use to which it's put, the function it serves, and so on. And if we look at the word more carefully than Aristotle did, we find many more varieties of complexity. So for example, if I tell you that I painted my house brown, you know that it means I painted the exterior surface brown. If I want to tell you I painted the interior surface brown, I have to say I painted my house brown on the inside. Markedness, it's called. Like if I tell you I climbed the hill, I went up. But if I can say I climbed down the hill, but I have to add something to tell you I was going down. Well, house is the same. It's basically a surface, an exterior surface, although we can complicate our description of it and focus attention on the interior surface. And it's much more complicated than that. It's not just a surface. If it was a surface, only a surface, then you could be near the house if you're inside it. If you're inside a mathematical cube, you're near the cube, because the cube's just a surface. We can't think about it like that. The way we use the word near or in or something, it's not just the surface. It's a closed surface, and it doesn't even have to be closed. Like if you take a lean-to, a thing which just looks like an upside-down L, there's an inside and an outside. If you take a mountain, it's the same thing. It doesn't have to be an invented artifact. And without proceeding, as you go on, you find the simplest word you can think of. Book, tree, person, anything you like, has immense layers of complexity, which are barely understood. I mean, investigating them is also a scientific problem. Barely the surface has been done. So the words seem just natural to us, but that's like navigating seeming natural to an insect. It doesn't mean it's simple. It just means it's the kind of thing we're built to do. And if you want to look at it from the if you want to discover what it's about, you have to look at it from the outside. Looking from the inside doesn't help. And you have to look at it the way Galileo looked at the fact that you drop something, it falls up, and falls down instead of up, and at a particular rate, and as a particular function of time, and so on and so forth. And those turn out to be extremely hard problems, and the beginnings of modern science.
Some of what you're talking about raises the issue of the connection between language and perception. And there have been a variety of views on that relation. Probably the best known and the one that linguists have the least use for is the notion that your language affects your perception. I'd say at the opposite end would be the notion that there's nothing special about language. It's just part of that perceptual, or based in that perceptual apparatus. You really seem to occupy a middle ground.
Well, the first point of view, famous, is the Wharf Hypothesis, it's called, is that the nature of your language determines the way you see and understand the world, which it's been extremely hard to put any meat on that hypothesis. I mean, Wharf, who was a major linguist, happens that he was an insurance salesman, but he was made extremely important contributions to linguistics. This hypothesis is the least of his contributions, and his actual proposals, while they kind of seemed persuasive when I was a college student back in the 40s, as soon as you think about them, they're not very persuasive. So one of his main examples was that one of the languages he was studying was Hopi, and he argued that Hopi has a different way of dealing with time than what he called standard average European, which would include English. So you and I think of time, at least I do, I assume you do, as a kind of a line with yourself standing on the line, looking forward toward the future and over your shoulder toward the past. And he argued, well, that's because European languages have past, present, and future tense. But Hopi doesn't have that system. They have some other system. He said they don't think of time that way. Well, there are a couple of problems with that. One problem is that English doesn't have past, present, and future tense. So if you looked at English the way he was looking at Hopi, what you would say is that the way we think of time is past and non-past, and then there's a bunch of modalities like necessity and optionality, and among them is futurity, just one of the modalities, because that's the way English syntax works, but we don't think of it that way. So how do we know that the Hopi don't think of it that way? It's not in their language either. And most of the examples kind of collapsed from that kind of analysis. There has been an effort to try to find something, and there's been a revival of it in the last couple of years and some suggestive work. But if there's an effect, it's extremely hard to tease out on perception. There may be, but it's not going to be easy to find. On the other hand, the other extreme, the idea is, well, language is just part of perception. I mean, now we're back to things falling because it's their natural place. I mean, as soon as you look at perception, it turns out to be an extremely complex affair with none of the properties you superficially imagine. And those properties just don't look like the properties of language, which is a different kind of system. I mean, it just, prima facie, it would be very surprising if language were a reflection of perceptual capacities. The one obvious reason is that we share, to a very substantial extent, we share our perceptual capacities with other primates, but they don't have language. So something's different. And the question is what it is. It turns out to be radically different as soon as you look into it.
Perception leads me to think about production. I'm going to ask a somewhat selfish question because it relates to my own particular research interests in the last few years. I've been doing a lot of work on sign languages. And at first, they seem to be quite radically different from spoken languages because you're not speaking. And I think, to my mind at least, one of the great contributions of modern linguistics was to legitimize the notion of sign language.
Yeah, that's very modern. After the days when you were a student, in fact, as you know. It's really the last 20 years or so that it's been discovered that sign language is a human language with very much the properties of the kind we're familiar with. And that came as a big surprise. And now sign language is, by linguists at least, studied as a language just among other languages. Like, as you know, at MIT, there's one graduate course every year, which is called unfamiliar languages or something. It can be a language of Africa or something like that. But a couple of years ago, the language chosen was American Sign Language. It's just another language. Let's try to figure out how that one works. And the similarities between sign, there are many different sign languages, of course, and they're mutually incomprehensible, but the properties of these languages turn out to be remarkably like those of spoken language. I mean, even their neural representation turns out to be similar. So, it was originally assumed that sign language would be mostly right hemisphere specialized because it's visual. Well, it turns out to be left hemisphere specialized in very much the way spoken language is. And if you look at that work by, I'm telling you things you know better than I do, so I feel funny saying it, but if you don't mind not laughing, the work of, by people like, say, Ursula Bellugi and Ed Klima and their lab has led to some discoveries about the neural representation of spoken language, which are surprising too. Turns out the left hemisphere specialization is kind of local rather than global. So like for discourse construction, it seems that right hemisphere dominance is significant, whereas for word or sentence construction, it's left hemisphere specialized. And something similar seems to be true of sign language. Discourse looks right hemisphere specialized, but sentence construction or particular sign construction looks pretty much the same as the spoken language, which is a surprise because the spoken specialization is near the motor areas, and they're just totally different motor areas for sign. So lots of things are coming out which are pretty surprising and are shedding new light on spoken language, but this just looks like another normal language. Actually, acquisition of sign follows the same, as far as is known, essentially the same course as acquisition of spoken language at the same times and the same maturational process and so on. So it has been extremely illuminating. Also, there are apparently invented sign languages, as far as anyone knows. The one that Judy Cagle and others are studying in Nicaragua looks as if it was invented, not borrowed, or by somebody who did invent it, but just invented by the community, the signing community. So it's a case of a very recent, apparently, invention of a language which looks like pretty much every other language we know.
It seems to happen when you simply bring a community together.
Yeah. Actually, there's some cases on record, few, not many, of children who have invented their own sign language. There's one famous case, the one studied by Susan Golden Meadow, and they found a couple of children, cousins, who were non-hearing, but whose parents were hearing, and the parents at that time were indoctrinated not to teach the children sign. So deeply indoctrinated, they were taught not to make gestures. So, parents would walk around with their hands behind their backs. Well, it turned out that these kids, on their own, just playing together, invented a language, a sign language. They were found at, I think it was about ages 3 and 4, and what they were doing without the parents' knowledge, just something they did when they, or if the parents saw it, they didn't know what was going on, some language that they had created. It was at the level of the character of spoken 3 or 4 year old language. Well, of course, as soon as the kids were found, they were put in an environment where they learned American Sign Language. So experiment ended. But it looked as though it was a spontaneously invented normal human language by a couple of kids in a single generation.
The legitimation of sign language, does that raise issues about the connection between language and speech? At least when I grew up academically, we thought of speech as essential to language.
It's certainly a challenge. I mean, it's a devastating challenge to it. It seems to indicate that whatever is special about language may be modality independent. I mean, how independent, we don't know, but at least sign and spoken language seem to share deep characteristics, to develop in pretty much the same way, and as to the little that's understood, to have the same kind of neural basis. So yeah, that does dissociate language from speech pretty sharply, or at least a large part of language. I mean, it indicates that whatever the sensory motor apparatus, which is, there independently of language, and it's not all that different than other primates and even mammals, it's certainly imposing constraints on what language is, but it looks like those constraints are much weaker than one would have assumed, say, 20 years ago. And that whatever else is that the nature of the computational systems is somehow much less dependent on the specific form of externalization than one would have taken for granted in the past. I mean, that doesn't mean that the study of sound structure of language or production is any less interesting than it ever was. It just seems that it's less essential to the nature of language.
Your most recent work is quite novel. Can you give us a bit of a flavor of some of this new work?
The so-called minimalist work? Well, it's known to any biologist or anyone who thinks about it that if you look at the nature of an organism, there are a number of different factors that enter into what the nature is, like, say, the visual system of a cat, let's say. I mean, one factor that enters into it is the genome. What's the genetic basis for the development of a cat's visual system? So that's one factor. Another factor is what's the actual visual experience that the particular cat had. And it's known experimentally, it's been known for about 40 years, that you can modify the very early, first couple of weeks, the visual experience, in a way which will change the structure of the visual system. It'll even change the neural structure of the system if you present, say, horizontal lines versus vertical lines in the first couple of weeks of life. So one factor is the genetic endowment. Another factor is the experience. If you take human language, there's a very rich genetic endowment that says we're going to have a language of a particular type. I mean, a Martian looking at us the way we look at, say, bees, would say we're all talking the same language, just even less varied than bees. There's a lot of different species of bees. There's only one species of humans, and they seem to have almost the same language from the point of view of an outside scientist looking in. So there's a rich genetic endowment that says, got to be one of these things. But there's also an affective experience, like, we're talking English, not Swahili, so that's some affective experience. But then it's also known that there are other factors, just the way the world works, like chemical and physical laws, or for language, probably the way computational systems work, what efficient computation is, and so on. And that's another factor that enters into what the outcome is. That's an extremely hard problem in biology. It's, you sort of study it, but it's out on the periphery. It's a hard problem. And the work that you're referring to in language, the recent work, is an effort to study how those factors enter into the nature of language. So how do principles of efficient computation, for example, enter into the properties of the language systems that we see. And it's controversial. This is very recent work, but at least my own opinion is that it turns out to be a major effect. And a lot of things that we thought were specific principles of language may in fact just reduce to the way efficient computational systems operate. I mean, at this point, it wouldn't come as an enormous surprise. I mean, I'm not suggesting it, but it would not come as an enormous surprise to discover that some of the crucial factors in, say, insect navigation are also showing up in human language and contributing to its nature. But that's research topics underway and properly very controversial.
Thank you, Noam. I hope we've learned a little bit today about linguistics. We have some time for questions, if you would.
Yeah, my question is, you often express doubts or question the notion of a publicly shared language, but couldn't we think of, say, Standard English or the Latin of the Middle Ages, academic Latin, as something like a invented shared language?
Actually, it's odd that these are called my doubts. Those are the doubts of every linguist. In fact, one of the first things you study in the first freshman course, usually it's done, you're taught a joke that was attributed to Max Weinreich, that a language is a dialect with an army and a navy. But there's no such thing, things are called languages because of colors on maps and, continuity of empires and all sorts of things. But it's certainly true that, within, like Mark and I and you, to some extent share a language. We're all talking to each other without too much trouble. If a linguist were looking at the three of us, they'd say, well, there's three different languages there which are kind of very similar, so they can get by. Over some range, you can decide to call the more or less similar languages a shared language if you want. It's not a linguistic observation. It's a practical discussion. Sometimes things are invented. Like if two professional linguists are talking, we're going to talk our own language, which nobody else is going to understand because there's all kind of special concepts in it and all sorts of other things. And that's a shared language. I mean, if I talk to, there are things I can talk about to monolingual Japanese, which I can't talk about to my children, let's say, because we just share some sub-language that's purposely invented. When you talk about Standard Latin, it was kind of something like that, partly ossified, partly created. But these are not linguistic notions. That you can draw the lines where you feel like.
Professor Chomsky, the expression, the lexicon, came up in the discussion. As you know, colleagues of yours at MIT tell us there is no lexicon. And in fact,
here we are. He's one of the people who's done the major work showing there is no lexicon.
And in fact, there are no lexical categories, adjective, verb, nouns. Any personal views on the existence of lexical categories? Or
categories? No, that's not lexicon. But categories, yes, like noun, verb, adjective.
Yes,
so.
Exactly.
Yeah, well, there is a view which I think is compelling and suspect is probably right, that the atoms from which bigger constructions are formed, what I'm loosely calling the lexicon, though it turns out to be pretty complex. Again, I defer to Mark, who's been working on the complexity of it. But abstracting away from that, there are some kind of atoms out of which expressions are formed. Question is, do they have categories? Like, are they in the categories noun, verb, adjective, and preposition, and so on? And there is a view, which I think, to which you're referring, which seems to me plausible, is that no, what there are really are roots, and the roots are category independent, and then there are particles, which in some languages you actually see, like they have a morphological realization, but in English you overwhelmingly don't. And it's the connection of those particles, which are in the head, small elements, which are in the head but only come out of the mouth in some languages, not others, that determines whether the thing is going to function as what we call a noun or an adjective. And that has things going. I mean, there are languages where this is almost obvious on the surface, like the Semitic languages. I mean, it's not 100%, but the basic structure of the Semitic languages just has roots and then ways of putting them into vocalic patterns, which turns them into what we would call, from our point of view, a noun or a verb or an adjective or something. But the claim that you're referring to is that that's basically the way it works cross-linguistically, which could well turn out to be true. I mean, what looks obvious to us on the surface is usually wrong.
Excuse me. There's a debate among some cognitive scientists and philosophers about whether we think in or with our natural language, English, say, or if there's something else going on, often called mentalese. I was wondering, first of all, if you think that question has actually been posed in any coherent manner, and if so, what your opinions about the answer might be.
Well, one of the problems with the proposal, I mean, I think there's probably something to it, but one of the problems with the proposals is comes out as soon as you ask yourself, what do we know about mentalese? Okay, so people talk about the language of thought, my friend Jerry Fodor, for example, and, maybe he's right, but what do we know about the language of thought? Well, it turns out it's English, or Italian, or whatever else the person who's writing about it says. So we really don't know anything much independent about what the language of thought, mentalese, is supposed to be. That doesn't mean it's not there. It just means we don't know. There's some reasons for thinking there must be something there. I mean, there are non-speaking organisms like monkeys and apes and infants who seem to do things very much like what we call thinking, but don't have the language to express it. So it looks as if there's thought going on, but somehow without language. And furthermore, I mean, unfortunately, there's almost no science here, so you really have to deal with intuition and introspection. If you introspect, it's almost obvious that there's thought without language. I mean, a very common experience, which we all have all the time, is to say something and to realize, no, that's not what I meant, and then to try to say it some other way, which maybe gets closer to what you meant, and then you try, maybe somebody else says it, and you say, oh yeah, that's exactly what I meant. Well, all of this seems to presuppose that there's something that you meant, and whatever it is that you meant, it's apparently not what you said, otherwise the problem wouldn't arise. And to try to figure out what it is that you meant, well, that's a problem of what thought is about. Unfortunately, there are very few ways of studying what thought is like other than through the medium of language. And that's why it's really hard. I mean, there is work on infants and other organisms which sheds a lot of light on it. So if you read a book like, say, Mark Hauser's book, Wild Minds, he's a primatologist, or a recent book by Anne and David Premack called, I think, Original Intelligence, which is mostly about non-human primates. They have plenty, and other organisms, not just like dogs and so on. They have plenty of evidence of what looks, it's hard to describe it without calling it thinking. It looks like what we would call thinking, but plainly without anything like what we would call language. And maybe out of that will come, and there's work on young children and so on too, which seems to bear on that. But so if you ask my opinion, my guess is, yeah, there's some kind of system of thought in there, which we can only get very limited access to at the moment from the outside. I mean, from the inside, of course, we all have it.
Thank you. I think we've learned a lot today. Thank you very much.